Alright, so now the next question or problem here is calculate the amount of water, this time in grams, produced by the combustion of 10 moles of methane. So the same thing, you have to write down the balance equation for the reaction, and there is CH4 plus 2O2 giving you CO2 plus 2H2, that's fine. Now, here as per the balanced chemical equation above, you see that 1 mole of CH4 produces 2 moles, right? It is 2 moles, MOL, you just write 2 moles of H2O. This is as per the balanced chemical equation here. Now you are given 10 moles of methane. So now 10 moles of CH4 produces how many? Let's take it as X. Now since it's a case of direct proportion, you can just cross multiply to the same thing. Alright, this is 10 moles of CH4 multiplied by 2 moles of H2O. So the whole thing now divided by this 1 mole of methane comes down of CH4. Like mole of methane get cancelled. So finally 10 into 2, it is 20, right? You have 20 moles of H2O. Now you know that 1 mole of water, it is equal to 18 grams, that's molar mass. So to express this in terms of grams, what you can do is, you can also make use of this unit factor. If you remember, this is 20 moles, right? 20 moles of H2O. Now the unit factor, when I say unit factor, what I'm going to do is, I want to get rid of this unit mole here. So for this, we know that 1 mole of H2O is 18 grams, isn't it? So this is the molar mass of H2O water. So mole and mole will get cancelled. So finally, when you multiply 20 by 18, it is 8 to 16. Sorry, 18 to 36, 360 grams. So in terms of grams, it is 360 grams. Or if you write this in the scientific notation form, it becomes, decimal point this side, 3.60 into 10 raised to the power 2 grams, something like this. So this is now the amount or the mass of H2O formed in grams when 10 moles of methane is burned, right? Okay, that's it. Now the next problem, calculate the amount of water that is in grams produced by the combustion of 4 grams of methane. This time you are given the mass of methane here, not in moles but in terms of grams. So let's see how we do this. Solution number 5. Again the same thing, CH4 plus O2 giving you CO2 plus H2O. You may have any other equation here. So I'm just taking this methane, right? Since it's easy to understand. Now when you go to balance the equation, this is 2H2O and 2 here, right? Alright, so now this 4 grams of methane. 4 grams of methane, if you express this in terms of moles, it's going to become, this is 16. 4 3 is 12, wow. Okay, that's it. So let's see. You can put it this way. As far as methane is concerned, its molar mass. See, molar mass of methane is 12 plus 4, 16 grams, right? So when you have 16 grams, it is 1 mole. 16 grams is 1 mole. And when you have 4 grams, it is how much? You cross multiply, it becomes 4, H is equal to 4 grams. Okay, into, that is 4 grams into 1 mole there, divided by 16 grams. Gram get cancelled, 4 ones, 4, 4, 16, it's equal to 0.25 moles. So this is 0.25 moles. Okay, just keep this in mind. Now, as per the balanced chemical equation above, we see that 1 mole of CH4 produces, or it gives, you have 2 moles of water, right? 2 moles of water. You can also take this mass in terms of grams directly, but I'm sort of taking it first in terms of moles. So when you have 0.25 moles of CH4, this will produce, so how many moles of water? Let's take it as X here now. Cross multiply, X is equal to 0.25 moles of, this is CH4, right? CH4 into, this is 2 moles of H2O divided by this 1 mole of CH4 comes down, right? In fact, you know, write all these, but still, for your understanding, I'm writing it here. X is equal to 2 times this number, 0.25 into 2, it is 0.5, right? 0.50 moles of H2O, right? H2O. Now, since you're asked to find this in terms of grams, mass of water produced in grams, here 0.50 moles. I'm going to use this unit factor as I did earlier. See here, to get it in terms of grams, see 1 mole of H2O has how many grams? It is 18 grams, right? 18 grams. See, here now, mole and mole get cancelled. Finally, you multiply 0.50 mole by 18. So you will now get 10 here, right? And then it is 5 8 40, 4 remains, 1.9, that is 9 grams. You're going to get 9 grams. This is equal to 9 grams. So on burning 0.25 moles of methane, you will get 9 grams of water. That's it. Okay. So I had some doubt here with you. 0.5 from 0.5 into 18. 85, 90, 9 grams. Fine, this right? No problem, fine. Okay, now the next problem for you is problem number 5. So the next one is number 6. I'm sorry, it is number 6. Here, calculate find the amount of methane in grams required to produce. Yeah, this is a little different one. Let's see. Okay, you're asked to find the amount of methane this also in grams required to produce 15 moles of water. 15 moles of water on combustion. Let's see. The solution here. Once again, the same thing. You take methane on combustion, gives you carbon dioxide plus water. And to balance the equation, it is 2 here, 2 here. Now let's try to do it a little faster. So you are required to find the amount of methane required in grams to produce 15 moles of water. So as per the balance equation above, you see that 1 mole of methane produces 2 moles of water. So you can see this, that is 2 moles of water is produced by 1 mole of methane. So in that case, 15 moles of water will be produced by how many moles of methane? Get it in terms of moles first and then change it into grams, right? So what I'm going to do is, see here, as per the balanced equation above, we see that 2 moles of water, H2O, is produced by how many moles of methane? It is produced by 1 mole, right? By 1 mole of methane. Now you are given 15 moles of water. So to produce 15 moles of water, how many moles of methane is required? So we write 15 moles of water is produced by how many moles of methane? You take it as X, just cross multiply. X is, this is 15 moles, right? 15 moles of water into, this is 1 mole of methane. This is important here. The whole thing divided by, this is 2 moles of water. Mole and mole get cancelled, so finally this is equal to 15 by 2 is 7.5. 7.5 moles of CH4 is methane. So you require 7.5 moles of methane to produce 15 moles of H2O water. Now you are asked to get this amount of methane in grams. So what I do is 17.5 mole is a unit. You leave it as it is, multiplied by the unit factor. So what is the molar mass of methane? It is 16 grams, right? So the unit factor, 1 mole of methane is 16 grams, right? Carbon 12 plus hydrogen 4, right? So 16. Mole and mole get cancelled, so finally you multiply these to 7.5 by 16. 7.5 by 16, you get 6 5 is 30, 3 remains 6 7 is 42, 45, and then it is 5 and 7, 0 0, 12, 120. So this is something like 120 grams of methane. So you will see that 120 grams of methane is required to produce 15 moles of water. That's it. So now maybe one more example for you to work out, 1 or 2. Let's see. And then we'll move on to the next subtopic, that is limiting reagent. So I finished with these 2, right? Okay, one example for you. Find the amount of ethane in grams required. Question number 6 there. Number 7, right now, question number 7. Find the amount of ethane. Okay, I'm going to write in grams required to produce this. Required to produce 378 grams of water on combustion. That is, you're going to make ethane burn, and then you'll calculate the amount of ethane required to produce 370 grams of water. So the formula of ethane, when you write the solution, I'll just write the beginning part for you. Ethane is C2, it's 6. You're going to burn it, it'll combine with oxygen, and the product always is carbon dioxide and water in the case of combustion of alkanes. So when alkanes are burned, you'll always get carbon dioxide and water. Now you need a balance equation. carbon, 2 atoms here, you put 1, 2 here. And then the next thing is hydrogen is 6 here. Maybe I'll put 1, 3 here, 3 to 6. Hydrogen balance. Now oxygen, you have 3 here, 2 to the 4 plus 3 is 7. So I'll put from 7 is 7 by 3. Right? So this is the now balanced chemical equation for the combustion of ethane. And then now you make use of this balanced chemical equation, you can easily calculate the amount of ethane required in grams to produce 370 grams of water, right? So you can apply the same technique. First thing is to convert this 378 grams of water, you can convert that into moles, and then you see how many moles of methane. You can see 1 mole of methane on combustion produces 3 moles of water. And then to produce 378 grams, so this, you change that into moles. So that many moles of water can be produced by how many moles of ethane. And then the answer you get for ethane in terms of moles, you change that into grams. That will be the final answer. So you can try it out on your own. And then one more example for you is problem number 8. Find the amount of carbon dioxide. Find the amount of carbon dioxide, again in grams, produced by the combustion of it is 440 grams of propane. 440 grams of propane. So you will try this on your own. The formula of propane is C3H8. If I'm not wrong, okay, that's it. So these two problems you work out on your own. And now we are moving on to the next subtopic 1, and that is limiting reagents. We're going to start with what is known as limiting reagents. So now let's see what is this limiting reagents. Most of the time when these reactions are carried out either in the laboratory or in the factories where they manufacture these chemicals, it is generally found that these reactants, they are not present in amounts as required by a balanced chemical equation. That is to say that one cannot take the exact amounts that are required. There will always be some variation in the amounts of reactants that we take in order to produce these required compounds. It is generally seen that one reactant is in excess over the other. So the reactant which is lesser in amount of quantity gets consumed, and after that there will be no further reaction whatsoever be the amount of the other reactant present. So the reactant which is lesser in amount, it generally sort of limits the amount of the product formed. So such a reactant which is present in the lesser amount of quantity is called the limiting reagent. Now, based on this, we're going to do a few problems. Now, the final, as far as limiting reagents are concerned, you will see that they actually decide the amount, the final amount of the product formed. So now, we'll take down one example. So the thing here, the subtopic is limiting reagent, limiting reagent. So like whenever these chemical reactions are carried out, like here, to talk about limiting reagents, there has to be at least 2 reagents. When you have just one reagent, we can't talk about limiting reagent as such. So you should have at least 2 reagents. There may be more than 2 reagents, but here we consider examples in which 2 reagents, that is 2 reactants, are present in the reaction. and then we decide as to which reagent or the reactant is the limiting reagent. So the first example for you, let's take down the very first problem. It says 140 grams of dinitrogen gas, and it is 40 grams of dihydrogen gas. They are mixed to produce ammonia. That is NH3, ammonia gas. It is NH3. NH3 is the formula of ammonia. So you now going to identify the limiting reagent. Okay, limiting reagent in this situation or in this reaction, right? All right. So now, what we need to do here is first write down the balanced equation for this reaction involving the combination of nitrogen and hydrogen to give you ammonia NH3 is the formula. Now, all these are in the gaseous state, right? And to balance the equation, you have 2 atoms of nitrogen in 1 molecule of nitrogen. So I put 1, 2 here. And then hydrogen 2, 3, 6, I can put 1, 3 here. So this is now the balanced chemical equation for this reaction. Now, we see that 1 mole of nitrogen reacts with 3 moles of dihydrogen to give you 2 moles of ammonia. This is the standard expression. It can't be changed. So whenever you make nitrogen, that is dinitrogen, react with the dihydrogen, you will see that exactly 1 mole of dinitrogen will combine with exactly 3 moles of dihydrogen to give you 2 moles of ammonia, right? This is the standard expression now. You are given 140 grams of dinitrogen and 40 grams of dihydrogen. So now when you mix these two, when you make them react, if they are not present in exact amounts as required by the balanced chemical equation here, then in fact the gas or the reagent which is present in lesser amount will get consumed first, and then the reaction will stop, and finally the amount formed, that is the amount of the product formed, will depend or will be decided by the reagent which is present in lesser quantity. So let's see. What you are given here is 140 grams of dinitrogen. So this you change it into moles. Now there are different methods, right? You can divide this 140 grams by the molar mass of dinitrogen and you can get number of moles. Or 140 grams you change this into number of moles by using this unit fraction method. You can use different methods. So let's see. I'll just take it this way, right? Number of moles of nitrogen is equal to mass of the substance in grams, that is 140 grams, divided by the molar mass. You remember the molar mass of dinitrogen is 28 grams, right? So you have seen this expression earlier. So this is actually the mass of nitrogen, right, in grams, right? And this is the molar mass. This is given, right? This is given. And this is the molar mass of dinitrogen. So you apply the same thing. And when you simplify this expression, it is now 14 ones, zeros, 14, 2 is 28. 10 by 2 is 5. It is 5 moles of dinitrogen. So you have 5 moles of dinitrogen here. Next, I want to see the number of moles of dihydrogen. Number of moles of dihydrogen. Okay, again, that is given mass of the substance in grams. In the case of dihydrogen, it is 40 grams. You are given 40 grams of dihydrogen. The molar mass of dihydrogen, it should divide molar mass of dihydrogen, it is 2 grams. you simplify, gram and gram get cancelled. So find this is equal to 20 times. It is 20 moles. So you have 20 moles of dihydrogen. So you got to keep these two in mind. You have 5 moles of dinitrogen and 20 moles of dihydrogen. Now, this is the standard expression. You see, as per the balanced chemical equation above, what I do is 1 mole of dinitrogen requires 3 moles of dihydrogen to produce 2 moles of ammonia. So you just consider these two. What I will write as 1 mole of N2 requires how many? Okay, 3 moles, right? 3 moles of dihydrogen. You write it this way. Alright. Now, what we are given is 5 moles of dinitrogen, and then we have 20 moles of dihydrogen. So this is the static expression, the static requirement. And now when you have 5 moles of dinitrogen, then this will require, right? So 5 moles of dinitrogen requires how many moles of dihydrogen? This is what we got to find. So when 1 mole of dinitrogen requires 3 moles of dihydrogen, then 5 moles of dinitrogen will require how many moles of dihydrogen? Again, since this is a case of direct proportion, you just cross multiply and you'll get the value of x is equal to, I think this is 5 moles of dinitrogen, right? Dinitrogen here into, this is 3 moles of dihydrogen divided by, this comes down here, this is 1 mole of dinitrogen. So mole and mole get cancelled. Finally, your x here, 5 plus 15. So you require 15 moles of dihydrogen. 15 moles of dihydrogen. Now, the important thing that you need to know is your 5 moles of dinitrogen will combine with exactly 15 moles of dihydrogen, and you will get the product. Now, your 5 moles of dinitrogen requires how many moles of dihydrogen? 15 moles, right? You need 15 moles. But you are given 20 moles of dihydrogen. You are taking 20 moles of dihydrogen and making it combine or react with 5 moles of dinitrogen. So what amount you actually require is only 15 moles, right? But you have taken 20 moles. You don't need so much. That is, you have 5 moles in excess. So what I write here is, say this, you have, 5 moles of dinitrogen, and this 5 moles of dinitrogen requires only 15 moles of dihydrogen. But now you write this, but we have how much? 20 moles of dihydrogen, right? So when you make 5 moles of dinitrogen react with 20 moles of dihydrogen, what will happen is this 5 moles of dihydrogen will get over when 15 moles of dihydrogen combines with it, and then the reaction will stop, but you still have some more. There is 5 moles of dihydrogen remaining, so this dinitrogen will be your limiting reagent. But we have 20 moles of dihydrogen raw, which is in excess, we have 5 moles of dihydrogen in excess. So the limiting reagent is dinitrogen, right? Because dinitrogen, 5 moles of dinitrogen after reacting with 15 moles of dinitrogen will get over and the reaction will stop, and you will still have 5 moles of dihydrogen remaining. So this is in excess. Now the one which is lesser in amount as dinitrogen. So your dinitrogen becomes the limiting reagent. That's it. So this is about limiting reagent, the first problem for you. Now the second one, another problem for you is, let me write it here itself. Problem number 2. You are given 14 kg of, now this time it is in terms of kilograms, 14 kg of dinitrogen and only 2 kg, right? 2 kilogram of dihydrogen are mixed to produce ammonia gas. Fine. Identify the limiting reagent. Identify the limiting reagent, and also find the amount of ammonia formed. Find the amount of ammonia formed. Ammonia is NH3. So let's take the same equation, right? So solution number 2 for problem number 2: nitrogen, dihydrogen, ammonia. So now again, this time there's a slight difference here. The next thing is now finding the number of moles of dinitrogen, and you have different methods or ways of finding this. I've already taught these. Now to find number of moles of dinitrogen, you are given 14 kilograms of dinitrogen. So you have to find the or express mass here in terms of grams. So 14 kilograms, when you change it into grams, it becomes 14,000 grams, right? So it is 14,000 grams. That is the mass of the substance in grams divided by the molar mass. Molar mass of dinitrogen is 28 grams, right? So you will now simplify this. Gram and gram get cancelled. So this is 14 ones of 14, 1, 2, 3 zeros, 14, 2 is 28. So 1000 by 2 is 500 moles. So this is number of moles, right? So you have 500 moles of dinitrogen. Keep this in mind. And the number of moles of dihydrogen, you are given 2 kilograms, right? 2 kg. Change that into grams. 2000 grams divided by the molar mass of dihydrogen is 2 grams. It is 1000 moles of fine. Now, what we need to do is here. All right. As for the balance equation above, so let's start from here. See, you have 1 mole of nitrogen combining with 3 moles of dihydrogen to give you 2 moles of ammonia. So that's the standard expression you have. You can't change it. So what I'm going to do here is, see, 1 mole of dinitrogen requires 3 moles of dihydrogen to give you 2 moles of ammonia. Now, when you are given 500 moles of dinitrogen, so I write 500 moles of dinitrogen. Okay, this will require how many moles of dihydrogen? Let's take it as X. And now again, since this is a case of direct proportion, you just cross multiply. And here this is 500 moles of dinitrogen here into 3 moles of this is dihydrogen divided by this thing comes down here. This is 1 mole of dinitrogen. These two get cancelled. So finally, the required number of moles of dihydrogen here is 5000 into 3, right? So 5000 into 3 is, 500 into 3 is 1500 moles of dihydrogen. So now, see, you have 500 moles of dinitrogen. 500 moles of dinitrogen requires 1500 moles of dihydrogen. But you have only 1000 moles of dihydrogen. So this is in lesser amount. The required amount is 1500, but you have only 1000 moles. So this dihydrogen is your limiting reagent. So what we write is, but we have only 1000 moles of dihydrogen, right? So the limiting reagent this time, so the limiting reagent is dihydrogen. So your limiting reagent in this case is dihydrogen. Now the second part of the question says, and also find the amount of ammonia formed. Now the amount of ammonia formed is decided by the limiting reagent. You write, see, the amount of ammonia NH3 formed, that is the final product formed, is decided by, the limiting reagents. It is decided by the limiting reagents. That is hydrogen. Hydrogen, you have how many moles of hydrogen? Only 1000 moles, right? So based on this you will do it now. Now as per the equation here, see, 3 moles of dihydrogen produces 2 moles of ammonia. So you write this way, 3 moles of dihydrogen produces or gives, right, 2 moles of ammonia. Now you have how many moles of dihydrogen? You have only 1000, right? So 1000 moles of, okay, let's add it fully, moles of dihydrogen produces, okay, let's take Y moles of ammonia. Now since this is also a case of direct proportion, you just cross multiply, and your Y is now going to be, when I cross multiply, this is 1000 moles, right? You have 1000 moles, not 100. This is 1000 here. I'm for making these mistakes. So this is 1000 moles of dihydrogen. This is multiplied by 2 moles of ammonia. NH3. This is NH3 divided by this 3 moles of dihydrogen. Comes down, mole and mole get cancelled. So find this is equal to 2000. Again, same thing. You get 2000 divided by 3 moles of ammonia, right? So now this is the same thing. You're going to get 666.7 moles of NH3 ammonia, right? So this is answer in terms of moles. You can express this in terms of grams also. So what it is, 6.7 moles, right? Moles into unit factor. Making use of unit factor, that is 1 mole, right? 1 mole of ammonia, it is again 17 grams, right? N is 3, N is 14, each nitrogen has 14 raw, and plus 3 hydrogen atoms, that is 17, right? 17 grams is the molar mass. So now mole and mole get cancelled. Finally you multiply these. So whatever answer you get here, that becomes the amount of ammonia formed. Moles. Yeah. So the answer here is 1333.9 grams. When you express this in terms of scientific notation, the decimal point comes here 1.13339 into 10 raised to the power. Okay, shifting the decimal point to the left by 1, 2, 3, 4 digits, the term is power 4 grams. This is the answer. Alright, so in terms of grams, you get this as the amount of your ammonia formed in this reaction. So now next, I'll give you one problem to work out, and that is, number 2, number 3. Question number 3. Let's see. 280 grams of nitrogen is mixed with it is just 50 grams, right? With 50 grams of dihydrogen. So 280 grams of dihydrogen and 50 grams of dihydrogen are mixed. They are mixed to produce ammonia gas. Identify the limiting reagent and also find the amount of ammonia formed. I think this is fine now. So you can work out this problem on your own following the same method or technique. That's it. So I stop here. Thank you very much. Thank you.